Hello viewers, hope you're all doing good, and I also hope you're all learning Kubernetes very well. You should have known many concepts by now, and welcome to this video. And in this video I'm going to talk about um, persistent volumes and how you can use that in your deployment or in your pod. Um, right, as usual, I'm going to start a brand new cluster. So it's all in my GitHub repository. I'm going to cd to play directory and git clone my Kubernetes repository, cd to Kubernetes, cd to Vagrant Provisioning, and Vagrant up. So this is going to provision a 3-node cluster with 1 master node and 2 worker nodes. All of them are CentOS 7 virtual machines in VirtualBox. So once the cluster is up, I'll show you a demo of how you can create persistent volumes and how you can use in a pod. Okay, so while the machines are being provisioned, I want to talk about few things regarding persistent volumes and how you can use it. Right. Let me bring up my editor here. Right. Why do you want to use a persistent volume? So when you deploy a pod in your Kubernetes cluster, any data stored in your application is gonna be valid only till the pod exists. So when the pod terminates, when the node goes down and the pod gets rescheduled on a different node, the data won't be available on the new node. So the lifetime of the data is just the lifetime of the pod. So what if you want to have a persistent data? So that's when you got to think about using the persistent volumes. If you use persistent volumes, the application you're using can store data in the persistent volume, and even if the pod dies and the scheduler restarts the pod, it can again start using the data that it has previously worked upon. So that's why we are thinking about using the persistent volumes. How you can use persistent volumes? So in Kubernetes cluster, first you have to create a persistent volume. PV persistent volume. It's like any other resource. You need to write a YAML file, and you create a persistent volume. Usually, cluster administrators will be creating the persistent volumes, and the users of the cluster will be requesting the persistent volume. So the first step is to create a persistent volume, PV. So once the persistent volumes are available, the user has to request a persistent volume. So they have to make a request. So this is again a YAML file, and it's called persistent volume claim. So you're going to claim a persistent volume. So the users will be creating a resource called persistent volume claim, and then you create a pod that uses the PVC to get to the persistent volume. Right. So is this fully automated? So when you create a pod, when you create a persistent volume claim, and if you trying to use in your pod, will that provision the storage automatically? No. So there has to be someone who creates the persistent volume for you. So this is not entirely automated. So whenever you want to use a persistent volume, you have to request the cluster administrator beforehand to create the persistent volume for you. Right, this is static provisioning. So you tell your cluster administrator, I'm going to deploy a MySQL application or a web application. I need a persistent volume to store my web or MySQL database data. And then you tell him the size, tell him or her the size of your requirement. Say, I want 5 gig storage in the cluster for my web application, and then the cluster administrator creates a persistent volume with 5 gig, and you can then start using it. So before persistent volume is created, you won't be able to claim it. This is static provisioning. There is also something called dynamic provisioning that's automated. In that case, the cluster administrator is going to create something called storage class. Um, so when you request a persistent volume using PVC, the storage class, you define a storage class, and then based on the storage class, your volume gets provisioned automatically. And when you're done with your application, you can delete the you can delete the volume that got created automatically. So that's dynamic provisioning. But all dynamic provisioning is only supported by few providers. For example, you can use the Amazon's EBS, Elastic Block Storage, Google's Compute Disk. If you're using Microsoft Azure, you've got the Azure Disk, Azure File. They've got provisioners for all these providers. So it's the responsibility of the cluster administrator to create the storage class. And once the storage class is there, you have to refer that storage class in your persistent volume claim. Then you should be able to request a persistent volume which gets provisioned automatically on AWS, Google, GKE, or the Microsoft Azure. So in this video, I'm not going to do the dynamic provisioning. I'm going to show you a simple static provisioning. There are different types of persistent volumes you can create. If I go to Kubernetes.io, persistent volumes. So you can see different types of persistent volumes. So you can use the Google's persistent disk, AWS EBS, Azure File, Azure Disk. You can use NFS, iSCSI, Cinder, GlusterFS. It supports a whole lot of file systems. vSphere volume, host path, storage OS. So in this video, I'm going to start by showing you a very simple one, which is host path. It says single node only. Local storage is not supported in any way and will not work in a multi-node cluster. So I will tell you what are the limitations of using host path. And if there is time, I'll show you how you can do that. You can use NFS for persistent volumes. What other thing you need to know regarding persistent volume? Persistent volume, say for static provisioning, if a cluster administrator has created you a persistent volume of 10 gig, and in your PVC persistent volume claim you specified just 1 gig or half a meg request, then it's going to match the available persistent volumes in the cluster, and it's going to match depending on what you have requested. So once it matches the persistent volume, say for example you requested 1 gig and there is a persistent volume provisioned in the cluster for 10 gig and nobody else has requested that persistent volume, your PVC will be granted that persistent volume. So which means no other persistent volume claim can use this persistent volume. That's one-to-one mapping. So if a PVC is attached to a PV, then no other PVC can request that persistent volume unless you delete the pod and release the request. Once the request is released, you're done with that, then the cluster administrator will delete the resource and recreate it. So it's one-to-one mapping. You can't have multiple requests pointing to the same persistent volume. Life cycle of persistent volume. So there are, what happens when you delete a deployment or delete a pod that used a persistent volume? There are 3 options that you can pause for reclaim policy. So one is retain. That's the default, which means once the pod is deleted, the PVC, the persistent volume will still be there, your data will still be there, it won't get deleted, and no other PVC will be given this persistent volume unless the cluster administrator deletes the content in that persistent volume. So that's the default retain. And this is needed because even if your application crashes or shut down your application and you want the data for debugging purpose, so it will still be there in the persistent volume. The second one is recycle. Recycle is more for dynamic provisioning, so it's deprecated. And the last one is delete, which means when you delete the pod and when you delete the persistent volume claim, it's going to delete the persistent volume and the associated data as well. And access mode. So there are three access modes: read write once, read write many, and I think it's read only many or just read only. Okay, so there is a persistent volume. You've got a persistent volume claim, and you're deploying a deployment set with 2 or 3 replicas, for example. And read write once is this will get mounted as read write on one node. So if your pod gets scheduled on multiple nodes, only the first node will be able to read write to that persistent volume. All the other nodes will only be able to read. The second option is read write many. So it can be mounted on different nodes, and all your pods in your deployment set will be able to read and write to that persistent volume. Read only, it's just read only. It mounts the volume in your pod, inside your pod, from any number of nodes, and you won't be able to write to that persistent volume. Those are the three things. Yeah, I think that's it, and we'll wait for the machines to be provisioned. So it has done the master, it has done the first worker node, and it has gone to the second one, K worker 2. Okay, I'll pause the video here and come back when it's ready. Okay, Vagrant has provisioned all the 3 virtual machines. I'm going to copy the Kubernetes config file to my host machine here, so that I can run the kubectl command locally on my host machine to interact with the cluster. I don't have to log into kmaster to do the kubectl commands. So for that, I'm going to create a directory called .kube under my home directory, and I'm going to copy the config file from the kmaster. Okay, let's check the status of our cluster. kubectl cluster info. Cluster is up. kubectl get nodes. 3 nodes, all of them are ready. kubectl get kubectl version. Okay, so we are on version 1.13.1. Cool. Okay, so if I go to the YAMLs directory, I've created some YAML files for this demo. So if you clone my GitHub repository, you should be able to find them in the YAMLs directory. So these are the 3 files that I've created. One is to create the persistent volume, the other one is to create a persistent volume claim, and the third one is to use the persistent volume. Let's see what's in the persistent volume. So that's the first one we have to create. So it says the kind of resource that we are about to deploy is a persistent volume. You give it a name, pv-hostpath. Type, it's going to be local. Storage class name is manual. Capacity 1 gig. So I'm creating a persistent volume for 1 gig. Access mode, read write once. Host path. So what's the type of persistent volume that I'm creating? It's host path. So I've shown you the different types of volumes you can create, like Amazon, AWS, Google, Microsoft, Azure Disk File, NFS, iSCSI, Cinder. So in this case, we are creating a host path, which is easy to create, but it has got some limitations. So you have to bear in mind that host path is a directory in one of your node. So you're going to log into one of your node and create a directory, and when you run a pod on that node, it mounts that host volume in that node. So even if the pod dies, the data will still be there in your node in the directory. The thing to remember is if you're having a multi-node cluster, and you're deploying this persistent volume and a deployment set to use the persistent volume, it will work only if the node gets scheduled on the pod gets scheduled only on the node where you have created the directory. You'll be able to understand if I show you an example. So if I log into kworker1, the first node, so I'm going to create a directory called /kube. Let's change mode to 777. Okay, that's it. I've just created a directory. ls/kube, nothing is in there. Let's leave that for a while. Okay, let's try and create this persistent volume. kubectl create -f persistent volume. So if I do kubectl get persistent volume, we haven't got any persistent volume yet. Okay, persistent volume is created. Kubectl get persistent volume. So as you can see here, that's the name, PV host path, 1 gig of capacity. The access mode is read write once. Reclaim policy is retain, which is the default. Status is available. Storage class is manual. Claim, so nobody has claimed this persistent volume yet. Okay, so now let's create the persistent volume claim. Let's first have a look what's inside. So it's again very simple. So this is the request that you're creating to use a persistent volume. What you're saying is you're giving it a name, pvc-hostpath, storage class name manual. It must match the storage class of the persistent volume that we created previously. Access mode, read write once. If you say read write many here, it won't be satisfied because we don't have any persistent volumes for that access mode. Resource, so this is where you're requesting. So I need a persistent volume that has at least 100 meg of free space. Before doing that, I'm gonna change that to read write many just to show you what happens. kubectl create -f for -pvc. So if I show you kubectl get pvc, we haven't got any claims yet. So that's created. If I do that again, kubectl get pvc, it says the status is pending. If you look at pvc host path, so it says warning, provisioning failed, which means the storage class manual not found mounted by. So I get all these. So let's delete it. kubectl delete, because we haven't got any persistent volume which with access node read write many. So let's delete that. kubectl get pvc, nothing. So I'm going to edit that vi and change that to once, and now create it. Created kubectl get pvc. So you can see the status as bound now. So it has bound to the persistent volume pv host path, and the capacity of the volume is 1 gig. We only requested 100 meg. Read write mode, storage class, and so on. So if I look at the persistent volume now, so that's the name of the volume, capacity, access mode. The status is bound, and the claim is the persistent volume claim that has requested this persistent volume, which is pvc-host path. Okay, so we've got the persistent volume, we have created a claim. So now we need to create a pod or a deployment that can use this persistent volume. So let's have a look. Vi busybox, so I'm just using a busybox pod. So what you can see here is the volumes section under the pod specification. So this name can be anything. It doesn't have to match the persistent volume name. So you're just defining a volume, and the volume type is persistent volume claim, and the claim name is the persistent volume claim that you created. So we're going to use the persistent volume claim here. The container is just a busybox container, and I'm running a simple sleep command for 10 minutes so that I can show you how it gets mounted and accessing the data. And inside the container, you're doing a volume mount. This name has to match the volume name here, host volume. So host volume, and where are you going to mount? And I'm going to mount under /my data inside my container. Okay, let's go ahead and create this pod. If I do watch kubectl, and you have to bear in mind that we created the directory /kube in kworker1. So if this pod gets created in kworker2, then you will have problems. You won't be able to see the data. So let's see where it gets created. Kubectl create -f. So it's created, and it says the container creating. It's pulling the busybox image at the moment. So luckily it got scheduled in kworker1. Okay, so let's have a look at the pod. Kubectl describe pod busybox. So you can see what Docker image it's pulling, and the status is running. And you can see the mount, it's the /my data from host volume, and you can see the volume here. The volume type is a persistent volume claim, and the claim name is pvc host path, and it has started the container. So let's have a look. Kubectl exec is the command. Kubectl exec the container name, and you're gonna do ls. Okay, we've mounted that under /my data. My data. So that's mounted. So there's nothing in the my data. Let's try to write something. Kubectl exec busybox echo, or just touch a file. Touch my data hello. So that's done. Let's run the same ls command again. So I've got the file hello created in /my data, and I'm gonna delete this deployment pod now. Kubectl delete pod busybox. It's getting terminated. Right, the pod is terminated. Let's see what happened to the persistent volume claim and pv persistent volume. pv, pvc. So it says it's still bound, and the persistent volume is still bound. Let's delete the persistent volume claim. Kubectl delete pvc -host path. Persistent volume claim is deleted. So if I do that again, so now you have got the persistent volume is still there. Because the reclaim policy is retain, deleting the persistent volume claim will not delete the persistent volume. So, but you can see the status as released. The original PVC that requested this storage is still PVC-host path. So if I go to the kworker1 and look at /kube, there you see, that's the data that's persisted. So the file hello, we created that file from within our container. So from the container, we mounted the host path on this node, and we created this one. We created this file, and now we are on the node, and the file is still there. So that's data persistence. Let me delete this file, or I'll just leave that file. Okay, so what I'm going to do now is to show you what happens when you create a PVC again. The persistent volume is still there, the status is released, but as I mentioned at the start of the video, any other persistent volume claim would not be able to use this persistent volume. Although no request is pointing to this persistent volume, or no pod is using this persistent volume, still any PVC won't be able to request this PV. Let's try and create it again. kubectl create -f pvc host path. That's created. Kubectl get pvc. The status is pending. Kubectl describe pvc host path. It says provisioning failed. That's because it's still under retain policy. So let's delete the pvc. Let's also delete the pv. Kubectl delete pv host path. Okay, so now I'm going to show you what happens when you create this on a node that doesn't have it. So let's create the persistent volume again. -f pv. So kubectl get pv. Persistent volume is created. Kubectl create -f 4-pvc host path. Kubectl get pvc. So persistent volume claim is also created, and it's bound. So the persistent volume claim, we requested 100 meg, and there is the persistent volume with 1 gig. So it got it's bound to that persistent volume. So what I'm going to do now is I'm going to edit the pod specification and use node selector, which I've explained you in one of my previous video. Node selectors, and I'm going to point that to say demo server :true. So what I'm trying to do here is to make the pod schedule on the second node, but the persistent volume we created is for the kworker1, where we have got the /kube data. The /kube data in kworker1 has got the file hello, so remember that. So node selector, so whatever node that has the label demo server is set to true, that node will be used for this pod. But if you haven't got any nodes with that label, kubectl get nodes -l demo server equals true. So we haven't got anything. So let's attach the label kworker2 and set the label demo server equals true. So demo server equals true. So we've got one node with that label. So if we deploy that busybox pod now, kubectl create -f busybox watch kubectl. So now this should deploy the pod on kworker2, and let's see what happens. Cool. Error, unknown field node selector. So I guess it is node selector. Node selector. Okay, I think I know what it is. So it's not in the container specification, it's the pod specification. We're not scheduling a container to a specific node, we are scheduling a pod to a specific node. So it has to be properly indented, and it's node selectors. Node selector. Okay. Okay, pod is created, and you can see the pod got scheduled on kworker2. Let's wait for the pod. Okay, the pod is running. So now let's do kubectl exec busybox ls mydata. So there is nothing in /mydata, but if you look in kworker1 ls/kube, there is a file called hello. If I go to kworker2, ls/kube, nothing. So it has created the directory ls/kube, but it hasn't done anything. So because it has created the pod on kworker2, and we have defined the persistent volume with the directory /kube on the node where it gets created, you don't see it. So if I write something busybox touch my data hello, and if I okay, so I'll create one other file just to show some difference. My data hello to kubectl exec busybox ls/ my data. So you've got two files that got created, and if I go to kworker2 and do ls/kube, so you've got these two files, and if I go back to kworker1 and do ls/kube, you only got hello. So that is the difference for host path. So host path is generally not used in the production environment, because the host path, as the name specifies, it's available only on the node. So if you create a host path and you create a deployment set with multiple pods, the pod will be able to write only on one node, and the other pod on the other node won't be able to see what's on the volume, because the volume is specific to the node. Right. One other thing I wanted to show you is the reclaim policy. The default reclaim policy is retain. So I'm going to show you how to use the delete policy. So let's take a look at kubectl get pv pv host path -o YAML. So the persistent volume reclaim policy is retain. I just want to copy that one and modify the persistent volume. So persistent volume reclaim policy, if I set that to delete, kubectl get all. So let's delete all the resource we created. Kubectl delete pod busybox. Okay, the pod is deleted. If we haven't got anything, kubectl delete pvc host path, and we'll also delete the persistent volume pv host path. Okay, I'm gonna edit the container pod specification, remove the node selector, and what we're gonna do now is I'm going to go to okay, let me first show you. The only change we have made is to the persistent volume, and we have added the persistent volume reclaim policy as delete. We don't need to go through the whole part thing. We can just create the persistent volume and create the persistent volume claim. kubectl create -f 4-pv host path. Persistent volume is created. Kubectl get pv host path 1 gig, read write once, and if you see here, the reclaim policy now is delete, and the status is available. So no PVC has requested this persistent volume. So let's create the persistent volume. Claim PVC. That's created. If I do kubectl get PVC, so the persistent volume claim is created and the status is bound. And it says the claim has been done by the PVC host path PVC. Okay. So now if I delete the kubectl, if I delete the persistent volume claim, say for example I've used this persistent volume claim in one of my pod like before to use the persistent volume, and I've deleted my pod and I'm going to delete my PVC. So since we have set the reclaim policy to be deleted, deleting the persistent volume claim should automatically delete the persistent volume, but you will see in a minute that it didn't delete the persistent volume. I'll show you why. kubectl get PV. So it says the persistent volume is still there, but according to the reclaim policy set to delete, it should have deleted the persistent volume. But you can see the status has failed. Let's have a look. You'll find in a minute why it didn't delete the persistent volume. kubectl describe persistent volume PV host path. Warning, volume failed delete persistent volume. So the host path only supports /temp but received provided /kube. So what we basically did was we created a directory /kube for the host path volume type. So the automatic deletion of the persistent volume will happen only for /temp. So let's go and do that. Try that out. kubectl delete PV host path. So we haven't got any PV or PVC now. Okay, let's modify this. VI persistent volume, I'm going to change that to /. What did I do? /temp /kube. So I just modified the directory to be /temp /kube. So in here, if I go to kworker1 and make directory /temp /kube. Okay, so ls temp kube. So this is going to be my persistent volume on the host on the node kworker1. So let's create it. kubectl create -f PV host path. So that's created. If I do kubectl get persistent volume, the reclaim policy is delete. It's available, so no PVC has requested this persistent volume. Let's create the PVC. kubectl get PVC, so that's bound. kubectl get PV, reclaim policy is delete, and the claim is done by PVC host path. So now let's check. Now let's delete the persistent volume claim. kubectl delete persistent volume claim PVC host path, and let's check if it has actually deleted the persistent volume as well. kubectl get PV. There you go. So there is no persistent volume. So if you create a directory under /temp, which is the only directory path the automatic deleter is supported, then when you create a persistent volume, when you delete a persistent volume claim, it's also going to delete the persistent volume. Only when you set the reclaim policy to be delete. So that's the main thing I wanted to show you. The default reclaim policy is retain. So when you delete the persistent volume claim accidentally, you don't want to lose the data. So the default reclaim policy is retain. You will still be able to access the data even if you delete the resources and the persistent volume claim. And reclaim policy delete, as you've seen, it will delete the persistent volume as well. Actually, I wanted to check if it has deleted this one as well. No, it still leaves the directory. It only deletes the resource in your Kubernetes cluster. Right. I think I ran out of time, but I'll quickly show you. If you want to have NFS instead of host path, what you can do is vi4-pv host path. In here, instead of the host path type, you can say, for example, on my host machine, if I've got NFS utils installed, sudo pacman -NFS utils, it's not installed. No, it's installed. It says it's going to reinstall. So basically, I've got the NFS server installed on my host machine. If I make a directory, for example, /temp /srv NFS kube, So I've created a directory on my host machine. I'm going to export this directory so that the NFS clients can access my directory. Sudo vi etc exports. This is the file where you specify what directories to expose and what clients to expose to. Say I say I want to export the directory NFS Kube to 172.42.42.star or 0/24 with read-write option and maybe sync. Basically, the IP address of my Kubernetes nodes. Or if you want, you can put star so that any NFS client that has access to this server will be able to mount this NFS directory. I can save that and then run sudo export fs-r, and if you do sudo show mount -e or just show mount -e, I haven't started the NFS server yet. Okay, in here, instead of hostpath, you can do NFS and server, the server name or the IP address. In my case, if I put the IP address 1095 something, IPAS 1095.65.213 and the path SRV NFS Kube. So that's the persistent volume climb. So what you have to bear in mind is all the nodes in your Kubernetes cluster should be able to should be able to reach this host IP address, the NFS server, and it should be able to mount it. So if I do show mount now, systemctl status NFS server, it's not running. Sudo systemctl start NFS server, systemctl status NFS server. Okay, that's running. Let's save this one, and back in, let me log into one of the node. You just have to make sure it can mount it. Say for example, mount 10.95.65.213:SRV NFS Kube to mount directory. Okay, so I think I need to reboot my host machine. I'm in the middle of recording this video, so I won't be able to do that. But make sure if you have set up a proper NFS server, and make sure your Kubernetes nodes can mount the NFS server, and then you should be able to use the this persistent volume climb. The only option are required are the server name and the path to mount. And then you can use the persistent volume climb as usual, and you can create a pod. It doesn't have to be specific to any node. It can be on any node, because the actual volume is itself on a different NFS server. So when you deploy a deployment set with multiple replicas, any pod can go to any node, and each node should be able to mount the common NFS directory. And you also need to make sure the access node read-write once or read-write many. For NFS, if you put as read-write many, all the nodes will be able to mount in a read-write mode. Okay, cool. I think that's all I wanted to show you in this video. If this is a very interesting topic, persistent volume, especially in the production environment. So if you've got any doubts or any questions, or if something is not working right for you, please leave me a comment, and I can try it out in my environment and will be able to help you. So thank you so much for your time today, and I'll see you in my next video. Bye bye.